Good afternoon, everyone, and welcome to this lecture. We are on Newton's law of motion. This is lecture number 4, and we will go ahead with what we were discussing in the last class. In the last class, we were dealing with problems in equilibrium, and we had seen that how are you going to solve problems in equilibrium? You just have to draw the free body diagram, find out the forces, resolve the forces along two directions, horizontal and vertical, or x and y, equate the forces and get your answer. So everyone remembers it, yes or no? In that category, let us also solve this problem, and we will discuss certain points here. I hope you can see this problem. The problem comes. The problem is like this. In the arrangement shown, what should be the mass of block A so that the system remains at rest? They can ask it in this way: system remains at rest, or you can say system remains in equilibrium. Also find out the force exerted by string on the pulley. This is one thing that they might ask sometimes in JEE Advanced. So what is the force exerted by the string on the pulley? So let us see. There is also one more force which is exerted by the floor. Remember this wedge or this inclined plane is also exerting a force on the block 2 kg. You also tell me what will be the value of that force exerted by the block. So I'll give you 2 minutes to think about this. How are you going to find this? Now, do one thing. Before doing this question, let us solve. Just leave some space. Instead of doing this straight away, let me give you my version of a simpler question first. So let us solve this question first, and then we will move on to that one. Let us say that this is an inclined plane of angle 30 degrees. Let us say this is mass m1, and let us say this is mass m2. Solve this one first, then you can do that. You have to find the ratio of m1 by m2 so that the system remains at rest. Solve this one first. Once we get the answer for this one, then we will move on to the next one. So for what value of m1 by m2 the blocks will remain at rest or the system remains in equilibrium? I'll give you 2 minutes to solve this. Yes, anyone got the answer for this? Or shall I solve it? Are you able to do it, or should I do it for you?
1/2, sir.
1/2, sir. M1 by M2, 1/2. How did you get? That is correct. How did you get it? So you draw the free body diagram. M1G T. This is the free body diagram of this pink wala block. Now this block is in equilibrium. This is the y-axis. This is the x-axis. There is no force along the x-axis. So the equation that you can make for this block is T is equal to M1G. Everyone understands this? Now we move on to the second block. We make the equation for the second block. This is M2G. This is T. And this is the normal reaction coming from ground here. Yes or no? Now remember, this block is not going to move up and down or right or left. This block is going to move like this along the incline. Yes or no? So it's better always to make the x-axis and the y-axis of this block for this block like this. This would be the y-axis for this block and this would be the x-axis. Do we understand this? Now once you see this no problem with this N2 because N2 is coming along y-axis. No problem with this T because T is coming along x-axis. But there is a problem with this M2G, the weight of the body. The weight of the body is not coming along either x-axis or y-axis. So what you got to do? You got to resolve it into two components. And how do you resolve it? Just remember this. Whatever component comes along x-axis is always M2G sine theta. Will you remember this? You must be knowing this. So this component will be M2G sine theta and this component will be M2G cos 30 degrees. Now you can make the equation. You can make the equation along y-axis. Along y-axis, if you see, the upward force is N2 and the downward force is M2G cos 30. So you can make the y-axis equation like this. We do not require this equation right now, but sometimes after some time we will require it. So the y equation becomes N2 becomes equal to M2G into cos 30. Cos 30 is root 3/2. So this is the value of M2. N2, if M2 is known, you can calculate the value of N2. If M2 is known, you can find out the value of N2. The question was not that though, but let us move on to the question. This is in equilibrium, so the upward force on the y-axis, this is the upward force on the y-axis. This should equate the downward force on the on the x-axis. This is the downward force on the x-axis. So now you can write the equation for these two along the x-axis. Along the x-axis, the equation will look like this. T is equal to M2G into sine 30. Sine 30 is half. Yes or no? Looking at this one and looking at this one, you can find out the ratio of M1 and M2. T is same. So M1G is equal to M2G by 2. So you can say the ratio of M1 and M2. M1 will be equal to M2 by 2 or M1 by M2 will be equal to half. Do we understand this? This is how you find out. There is nothing new. The only thing that is different, not new, is that for the block on the inclined plane, I have made x-axis and y-axis slightly different. The x-axis is along the incline and y-axis is perpendicular to the incline. That is the only difference. And why we have done that? To make our question simpler. Do we understand this? Now, since we have solved this one, and I hope everyone has noted down this one, then we can move on to the previous question. Now, let us solve the previous question and get the answer. In the arrangement shown, what should be the value of mass of the block A so that the system remains at rest? System remains at rest means what? The system is in equilibrium. So you have 2 minutes to solve it. Let me know if you have the answer. Do we have any answer or shall I do it? Anyone has any answers? Okay. So how are you supposed to do this? How many strings do you see in this system? 1 or 2? There are 2 strings in the system. So I have to call them by different names. Let me call the mass of this as M. So the weight is mg. Let me call the tension as T1. Tension on the pulley is T1. Tension on the pulley is T1. This would be T1. On the other side, tension is also pulling. So this will be T2. Mass of this pulley. The tension here is T2. This is T2. This tension on this block is T2. And this is 20 newtons. I hope everyone understands this, yes or no? Okay. Now let us move on to this block. This is 20 newtons, 2 kgs. I will resolve it into 2 components. This will be 20 sine 30. How much is sine 30? Sine 30 is half. So 20 multiplied by 30. This would be 10 newtons. Everyone understands this? And this would be 20 cos 30. Cos 30 is root 3 by 2. This will be 10 root 3. I have not made the thing perpendicular, so let me make it again perpendicular. So this will be 10 root 3. Everyone understands this? There will also be a normal reaction. Let me call this as N2 coming on this block. Okay. The system is in equilibrium. So let us write the equation for this pink block. This is the diagram for the pink block. You can write the equation for this block, and the equation will be simply T1 is equal to mg. Everyone got this equation? Let us move on to this green block. This green block has got a simple diagram like this. It is in equilibrium. So the equation of this green block becomes T2 is equal to 20. But the thing is, one side we have T1, the other side we have T2. So now we have to move on to the third block. The third block is this blue block. Now, if you look at the blue block, we'll have to make different x and y axis. So y axis would be like this, and the x axis would be like this. We understand this, everyone? Okay. Now we can look at the y axis. Y axis, we have n2 here and 10 root 3 here for the y axis. So the equation for the y axis for this block will be n2 will be equal to 10 root 3. No one is asking you this equation right now, so let us forget it. Now let us look at the x-axis equation for this block. Let me color it with blue color. Here we have T1 on the upwards. We have T2 in the downward direction. We also have 10 in the downward direction. So what will be the equation for this block? The blue thing. T1 upwards should be equal to T2 plus 10. Do we understand this? Now, as you can see, the value of T1 is here and the value of T2 is here. You can put the value of T1 and T2 from the other equations in this equation, and you will get the value of the mass. How much are you getting? Three kgs you will get. I hope everyone got. M will be equal to 3 kgs. Well done. But there is one more question which was hidden in this question, is the force on the pulley. Force on the pulley. Anyone could solve that? What is the force on the pulley? What is the force on the pulley applied by the string? Anyone got the answer for this? How are you supposed to find out the force on the pulley Q? How are you going to find the force on the pulley Q? Anyone with any answer? Okay, let me help you with this. This is the, yes, you got the answer, beta? Anyone? Okay. We have drawn the free body diagram of the pulley Q. This one is T1 and this one is T1. Yes or no? This was the free body diagram. T1, T1. Now, we have also calculated that this T1 was equal to M into G, yes or no? And we have now calculated the value of this M is 3 kg. So this T1 becomes 30 newtons, yes or no? Now, this pulley Q, let me color it with this color. This pulley Q has got two forces, T1 here and T1 here. Now, if I just draw this pulley just to make you understand as a point, this pulley is a point. There are two forces acting on this pulley. This one is T1 here and this one is also T1 here. Can you tell me what is the angle between these two forces? And you can see it from the diagram. See this T1, if I draw it directionally, this T1 is like this and this T1 is like this. You can easily tell me what is the angle between the two.
60, sir.
60, sir. That's it, sir. Remember, these are two forces. Forces are vectors. These are two vectors inclined at an angle of 60 degrees with each other. These are two vectors which are inclined at an angle of 60 degrees with each other. Let me remind you of something that you have already done. Vector A, vector B, both inclined at an angle of theta with each other. You know how to find out the resultant. The magnitude of resultant is given by this formula, under root of A square plus B square plus 2AB cos theta. Yes or no? Now you can tell me the force applied by the string on the pulley. The force applied by the string on the pulley F will be equal to under root of T1 square, one force, plus T1 square, the other force, plus 2 times T1 into T1 cos of 60. Do we understand this, bacha? And you will end up with the answer. What is the answer you are getting? You will get the answer as T1 into root 3 and T1 is your 30. So your answer would be 30 times root 3. Do we understand this? Yes or no? No, yes. Now, if you understand this, then I will give you an additional question. Can you find the force applied by the string on this pink pulley? This pink is also a pulley. Can you tell me what is the force applied by the string on this pink pulley? I'll give you 2 minutes. Pink pulley. Everyone has noted down this one. So I'm going to take it off. I'll give you 2 minutes to do this. Okay, anyone with an answer? Let me not waste much time and give you how to do this. This was T2. This was also T2. And you know what was the value of T2? T2 was 20 newtons. Yes or no? So if I draw them as a point, 30 Newton was here and 30 Newton was here. What was the angle between these two? What is the angle between these two?
120, sir.
120, sir. Correct, sir. 120 degrees is the angle. You can see it clearly. T2 goes like this and this T2 goes like this. This total angle has to be 120 degrees. So now you can put it in the formula. The force exerted on this pulley will be under root of 30 square plus 30 square plus 2 times 30 into 30 into cos of 120 degrees. Do we understand this? You can put the value of cos of 120 degrees and get your...
20.
Oh, sorry, 20. I've written it 30. Sorry. Let's write it at 30. So I've written the answer. Let me write this as 30. Let me make this as 3. Doesn't matter. Okay, do we understand this? So whenever you encounter such a question, please do it this way. Shall we move on to the next thing? We have done question on equilibrium. Equilibrium means force is zero. Force is zero means a particle will remain at rest, or if it is moving with uniform velocity, it will continue its uniform velocity. That was Newton's first law of motion. Now we move on to Newton's second law of motion. So that is the next heading, Newton's second law. And what does Newton's second law state? Anyone? What does Newton's second law state?
Rate of change of momentum, which is directly proportional to net force.
Okay, you can say it in this way. Rate of change of momentum rate of change of momentum is directly proportional to force. Rate of change of momentum is directly proportional to the force and takes place in the same direction as force. So basically it is saying dP by dt, rate of change of momentum is directly proportional to force, or it is saying dP by dt is equal to k, which is a constant multiplied by f. The value of this k actually comes equal to 1. So your Newton's second law of motion becomes dP by dt, rate of change of momentum, is equal to the force. That becomes your Newton's second law of motion. Do we understand this? Anyone knows this? Yes or no? Anybody noted this down? Everybody noted this down? Now, this is one way of writing it. The other way of writing it, you can also imagine it in this way. dP by dt becomes d by dt of
Excuse me, sir. Can you show your previous
m
one?
into v. Okay, write it. Write it. Let me know once you're done. Done? Okay. Now moving, done now? And moving ahead, I can write this dP by dt as d by dt of m into v. Normally, the mass of the body will remain constant. So mass will come out. It is dV by dt, and dV by dt becomes ma, or m into a becomes force. Or I can write it in this fashion. The acceleration of the body will be given by the net force divided by mass. This is the next way in which you can state the same Newton's second law. F is equal to ma, or acceleration of the block is F by m. We understand this, everyone? Yes or no? No, yes? Okay. Now, some points which you would have to remember for your theoretical concepts. Point number one, this Newton's second law is consistent with Newton's first law. In fact, Newton's first law is contained in Newton's second law. Newton's first law is a special case of Newton's second law. What special case? If the force is zero, the acceleration of the particle will be zero. The particle will either remain at rest or continuous uniform motion. So sometimes we say that Newton's first law is contained in Newton's second law. Do we understand this? Okay, well done. Now this, whatever we have written, is written in the vector form. Sometimes we might have to write it in the form of equation along x, y, and z axis. So if we have to write the Newton's laws of motion along x, y, and z axis, we will write it like this. I hope you understand. Force along x will be the rate of change of momentum along x. That will be equal to m into acceleration along x. Do we understand this? Similarly, for y-axis, we can write force along y will be rate of change of momentum along y. That will be equal to mass into acceleration along y. This is the way that probably we are going to use them. Z-axis we might not need, but if it is z-axis, the force on z-axis would be mass into acceleration along z-axis. Do we understand this, everyone? Every point is clear up till now? Okay. Now, third point, what we have to understand is this m into a. We are thinking of this body as a point mass. We are, even if it is a car, we are going to take it as a point mass. In chapter which is going to come up, center of mass, we will be treating bodies, many different bodies together. Right now, whatever we are going to do, we will be applying this whole equation F is equal to ma on a body, taking it as a point mass. When we go ahead, we will be writing equation for different point masses together in a system. This will come not now, but in the chapter which is coming up. Right now, we will be applying Newton laws on one particle and not on a system of particles. Do we understand this? Because when there is a system of particles, beta, then there are internal forces also between them, and internal forces do not change the acceleration of the body. They will cancel each other out. We will get to know more about these internal forces in the chapter that is coming up. Right now, we will just solve questions thinking of the bodies as particles. Do we understand this? Now let us, I hope everyone has noted this down. Now let us start with some basic questions, and then we will move on to some typical questions. Everyone has noted this? Okay, I'll give you time, don't worry. The purpose of this class is not to frighten you, is to make you understand whatever we are doing in the class. Once you are done, please let me know so that I can move ahead with some questions. Shall we move ahead? Okay. No. Half of them are saying yes and half of them are saying no. When all of you say yes, then only I'll move ahead, don't worry. Okay. So this is the first question. Remember, we might not encounter such questions because most of the question in Newton's law, the body will be placed on some surface or it will be hanging from some pulley or strings. But this is just to give you an example of what is the difference between this question and the other questions. Force F1 and F2 of magnitudes 50 and 60 newtons act on a body of mass 5 kg. This body is a free body. What do you mean by a free body? It is free to move anywhere. Now, if you keep a body on a surface, it can only move along the surface. But this is a free body. It can move wherever is possible. Mass is 5 kg. What is the acceleration of the object with respect to free space? Now, space is also free. That means there is no gravity. So you don't have to take the weight of this body. Do we understand this? So it's a very special question that has been made. The body is free to move. So basically, the body is somewhere in space, and then there are two forces acting on the body. The body has no weight because weight only comes when there is gravitational force. There is no gravitational force. The only two forces that are acting on this body is F1 and F2. Those two forces might be gravitational. I don't know. Can you tell me what is the acceleration of this body with respect to the free space? I'll give you 2 minutes to do this. Yes, anyone with any answer? Now, to solve this question, you might have to know the value of two angles. Sine of 37 is 3 by 5. Cos of 37 is 4 by 5. Do you know this? You might require this. Anyway, shall I do it for you? Okay, let me help you out. Now, since this body is free to move, it will move in the direction of net force. Now, how you can find the net force? There are two ways to find out the net force. Let me tell you the first way. The first way is very simple. You can see these two forces, F1 and F2. They are basically vectors. They are inclined to each other at an angle of 127 degrees. So you can find out the net force. How will you find out the net force? To find out the net force ka magnitude, you can simply put the formula root over F1 square, and F1 is 50. 50 square plus 60 square plus 2 times F1 F2, 50 into 60 into cos of 127 degrees into cos of 127 degrees. From there, you will get the value of F net. What is the value of F net that you are getting? Cos of 127 is same as sine of 37, but with a negative sign. Sine of 37 is 3 by 5. 1 5 will cancel 1 3, and you will get 60 into 60 square with a minus, and I think you will get the net force as 50 newtons. Are you getting it? Yes or no? Put the values. I can't help you with maths. If I keep on putting the values and showing you that you are going to get this, I will waste a lot of time and you will not be doing anything with your own hands. Put the values with your own hands. The value of cos of 127 is minus 3 by 5. Now put the values and you will get the answer. Are you getting?
Sir, yes, sir.
Okay. Now once you get the value of net force, you can find out the net acceleration. It will be 50 divided by 5. So the magnitude of net acceleration will be 10 meter per second square. That is way number 1 of doing this problem. Do we understand this? Everyone? Now let us look at a different way of doing the same problem. And in this different way, what will I do? I will show it to you. Don't worry. So everyone has noted this down? How did I do it in the first case? Now remember, that was a free body. It was free to move. Now, look at this diagram now. I'll do the same thing, but I will do it with the X and Y concept. So basically what I'm going to do is I'm going to break this force into X and Y components. So this is my Y axis and this is my X axis. Everyone understands this? Now, Along x-axis, I have unit vector I, and along y-axis, I have unit vector j. Everyone knows this? Now, we also know that this angle is 37 degrees. So this component of force will become F1 cos 37, and cos 37, F1 is 50, cos of 37 is 4 by 5. Yes or no? Do we understand this? Then this component of force, my dear friends, will become F1 sine 37. F1 is 50, sine 37 is 3 by 5. Everyone understands this? Now looking at these two oops, wrong color. Now looking at these two components, I can write F1 in the vector form. How will I write F1 in the vector form? F1 in the vector form can be written as minus 30i plus 40j. Do we understand this? Everyone, boys? Do we understand this? Okay. Now looking at this F2, gentlemen, F2 is only along I, so I can straight away write F2 in the vector form. How can I write F2 in the vector form? F2 is simply 60 along I. So this is along 60 along I. Then how do I find the net force, bacha? I just add these two forces and I will get the net force. So my net force would be in vector form. My net force will be minus 30i plus 60i. That is 30i plus 40j. Now, how do I get the acceleration, bacha, from here? I will divide the net force by the mass of the body, bacha. Mass of the body was given as 5 kgs. So this becomes 6i plus 8j. The acceleration becomes 6i plus 8j. This is the answer of the acceleration in the vector form. This is the answer of the acceleration in the vector form. You can also find its magnitude. If you want to find out the magnitude of acceleration, what you got to do is you need to do 6 square plus 8 square, and you will get the answer as same that I got there, 10 meter per second square. Do we understand this? So these are the two ways of doing this, but this type of question would hardly come. The body may not be in free space. The body would be probably on Earth. Gravitational force mg will be acting on the body. But if you get a question like this is how you need to solve it. Okay, so you got this, everyone? Well, then I will see you in the next class and we will move ahead with questions on Newton laws of motion. I hope you like this lecture. I saw some of you sleeping in the class. Well, if you don't get enough sleep, then probably you sleep early, and that's better. If you sleep in the class, that tells me that probably you are too much tired. Anyways, if you are getting tired at this age, before getting into the college, life is going to be very hard for you, beta. Trust me on that. So please, whatever time we have, please you utilize it correctly, beta. You're putting in a lot of effort, and I hope that we can get something from those efforts. Take care. God bless all of you. Bye-bye.
Thank you, sir.